Hello everyone, I'll be presenting blind source separation project. Imagine several people speaking in a room while multiple microphones record the sound. Each microphone captures a combination of all voices rather than a single one. As a result, the recordings we obtain are mixtures of the original signals. So our goal is to recover the individual audio signals even though we only observe their mixtures. Let's write down the goal is to recover original signals. How do we do this? What mathematical representation do we have of the mixing process? So we understand that our observed signals that we captured by our microphone is a mixture of sources. That's a mixture of different voices. Let's write it. So our observed signals, or the mixture of sources, is X. And how do we get this X? Let's represent observed signals as a matrix. And X is a product of multiplying two other matrices, where A is a mixing matrix. It describes how strongly each microphone captures each source, and S is the original source signals, for example, individual voices or instruments. So if we have two sources and two microphones, each observed signal is a mixture of the original sources. The first microphone records signal X1 is a combination of source 1 and source 2, or two voices. That looks next way. And the same works for the second microphone record X2. So this is the first microphone record, this is the second microphone record, two microphones, okay? This is our first voice, first person speaking, and this is our second person speaking, and both records are the linear combination of the sources. Our observed signals are linear combination of the sources. Why the problem to distinguish two sources or two persons speaking is difficult? We have only X known. Only X is given, which is observed signal. And the mixing matrix, the way that microphone captured first and second voice, is unknown, same as the source signal itself. Because we try to recover the sources without knowing how they were mixed, the problem is called blind source separation. What is our strategy to recover sources? So the goal is to find sources, as it was mentioned before, the original. And to recover them, we try to find another matrix, which we denote as W. Ideally, the matrix W should approximate the inverse of the mixing matrix, or the matrix A. So what we're looking for is such W that is approximately an inverse of mixing matrix. If we successfully estimate this matrix, then multiplying by the observed data x should give us the separated signals. To estimate this matrix, we use a method called independent component analysis. Or I will call it ICA. The key assumption of independent component analysis is that the original sources are statistically independent from each other. For example, different people speaking or different musical instruments usually produce different sounds. The algorithm searches for a transformation of the observed data that produces signals that are as independent as possible. So we distinguish our sources as much as possible. How do we do this? Before applying this ICA, we should perform a pre-processing step called whitening. How do we do this? First, we compute the covariance matrix of the observed signals. The covariance matrix measures how the signals vary together and helps us understand whether they are correlated. Next, we perform an eigenvalue decomposition of the covariance matrix. That looks next way, where E is the matrix of eigenvectors, and D is a diagonal matrix containing the eigenvalues. Using these matrices, we construct a whitening transformation. The transformation first rotates the data using the eigenvector matrix and then scales data using eigenvalues, our D, diagonal matrix. As a result, the transformed signals become uncorrelated, which drastically simplifies the separation problem. So our final algorithm overview. First, we collect our mixed signals, we compute covariance matrix, apply whitening, and then estimate separation matrix W, estimate separation matrix W, and use it to recover our sources. In the implementation phase of our project, we will estimate the matrix using fast independent component analysis algorithm, which finds components that are maximally independent. And this project demonstrates how linear algebra tools such as matrices, eigenvalues, covariance matrices, and linear transformation can be applied to solve real signal processing problem. Thank you.